So now we're going to be looking at u substitutions that will involve natural logarithms. So for example, here, you look at what the ugliest part of this integral is, and you just say, well, let me pick u equals natural log of x. And your derivative then, or du, sorry, your differential, is going to be the derivative of this natural log of x, which is 1 over x dx. And in the last few videos, I've been solving for just solving for the dx, but you can also, if you prefer, you can also just notice that this 1 over x dx is really appearing here, and you can substitute that in with a du, and at that point then you would have that your integral becomes the integral of u cubed and then du. The du taking care of all that dx over x, and your u cubed coming and showing in this form. So that would be your u cubed. All right, and then once you have it in that form, then you just integrate, in this case, u to the power of 4 over 4 plus c. And once you have it in that form, you take back your substitution, which is going to be the natural log of x to the power of 4 all over 4, and never to forget the plus c. All right, so I'll do a few more of these. So how about that one? It has a natural log and it has trig. This must be a crowd pleaser for sure. All right, so you take u equals, well, u equals 1. I was going to write the substitution right away. Let's discuss it a little bit. Well, tangent will not really help us because we have a natural log. So it seems like we should pick that natural log of the sine of x. And then when we do that, our differential of u is going to be the derivative of this. Now, remember, what is the derivative of the natural log of a function of x? You have to take the derivative of the inside, which in this case is going to be cosine x all over the inside, sine x, and that's going to be dx. So this one, what you could do is you can multiply by sine of x on both sides, divide by cosine of x, and you're going to have that sine x over cosine x of du is equal to dx. But sine of x over cosine of x is also known as the tangent. And with that, I can substitute in. So natural log of the sine of x, I said, was going to be u. I'm going to leave that tangent alone because with my dx, I'm going to get a tangent that will cancel it right here. So your dx becomes this, and that is going to be the tangent du. So tangent multiplies, tangent divides, it cancels, and I get that this is the integral of u du. I can integrate u squared over 2 plus c, and then I can just take back my substitution and write it as the tangent square of x all over 2 plus c. And that gives me that integral right there. All right, so let's take a look at this one. So this is going to be one that it doesn't have a natural log, but it'll result in a natural log. So for example, let's do sine x minus cosine x over sine x plus cosine x. All right, so that looks rather ugly, and you could try some identities to simplify it a little bit perhaps, but the easiest thing to do will be to look at that denominator and make that our u. And why would we think about that? Is because when you take that derivative, notice that the derivative of the sine is going to be your cosine, And the derivative of the cosine is going to be the negative sign. So this is going to become cosine minus sine of x dx. And now what can happen is if you solve it, if you solve for your du, or for your dx rather, dividing on both sides, you get that this is going to be du is going to be divided by cosine x minus sine x. All right, so let's plug that in and see how that works. So sine x plus cosine x, so the denominator is simply going to be u. Now let's leave this one alone, the numerator, so sine of x minus cosine x. Now in place of dx, I'm going to write du over cosine x minus sine x. And you're going to say, well, sine x minus cosine x is not the same as cosine x minus sine x. And I would agree, however, they're off just by a factor of -1. So let's rewrite this one as, in fact, I'm going to rewrite this first one as negative cosine x. Just as easier to put the negative out there rather than. So let's try to first agree that this factoring a negative gives us the same thing. When I do negative times cosine, gives me negative cosine. And when I do negative times negative sine, gives me positive sine. So I get sine minus cosine. So it looks like I did it right, but we want to confirm. So then we have du over cosine x minus sine x. And now you do see that the numerator and the denominator are the same. So you have, oops, I click the eraser button. Now I know where it's at. Becomes negative du over u. And now you remember that the derivative of this one, this is u to the -1. If you were to apply your power rule, would be -1 plus 1, which gives you a 0 in the exponent and a 0 in the denominator. That's a bit of a problem. So you have to remember then, oh, this is that one that becomes the natural log of absolute value of u plus c. And then you take back your substitution, and in this case would be negative natural log of u, which is sine x plus cosine x. Oops, that's right, cosine. Let's rewrite it. Sine x plus cosine x plus c. And that gives you your antiderivative, your integral. All right, that's quite a bit of practice on those. So we'll finish the video right here.